session. Yeah, the sample in the PowerShell module toolbox and templates for continuous delivery. We are going to talk about a module scaffolding system, and this is not the only one. So there are many of these systems available. For example, Fred in the back has also created something like this, and I think it's more it's very hard to compare them and to say which one is better. It's more a personal choice and what suits your needs and your requirements. Yeah, thank you for our sponsors that make this conference possible. My name is Raimund. I'm working for Microsoft Germany as a former PFE, now called customer engineer. My main topics, DevOps, DSC, PowerShell, everything around automation. And you can find me on Twitter, GitHub, LinkedIn, so the usual platforms, of course. And the credits for this session actually goes to Gail Kohlers and Johan Ljunggren. These two guys are mostly maintaining the project that I'm going to show you. And I'm showing this and I'm kind of advertising it because I was very surprised in how it helps creating a module that is not only just working, but has a very high code quality, plus all the practices and patterns that the community has built over the couple of years in just one solution. And the session objective is being able to create and publish a high-quality PowerShell module by implementing, I would not say a lot of, but all the best practices that the community has built. Of course, you have a configuration file, you can remove stuff that you don't want, but if you don't remove or don't shorten the file, then you actually adopt everything that we have. And what is Sampler? And this is almost the only slide that I have. A project that helps you build or outlining a module project. So usually a very simple module project has only a PSD1 file and a PSM1 file. But as soon as the code grows, you realize that having everything in just one file doesn't scale very much, right? So then you put it into multiple files. And the more files you have, the slower the module load time is, right? So one of my old modules is still delivered in, I don't remember exactly, but I think it's 95 or 100 files, roughly 100 files. And the module load time is about 30 seconds, which is pretty bad. So this concept here is getting all the files, putting it into one PSM1 file with little markers. I will show you how that works. So it increases the overall comfort for the developer, but also the comfort for the user and especially also the speed. So, some bullet points here. It forces you to start with a high-quality module right from the beginning. So it enforces Pester tests, it enforces linting, it enforces change management or changelog control. It is pretty extensible, so there is a lot of predefined tasks. We will have a look into one of them or some of them. But if you are not happy with the tasks or you need to have some additional stuff, then it's extensible. It runs on all operating systems where PowerShell runs. So by default, you have tests running on macOS, running on Ubuntu, and running on Windows PowerShell, and also PowerShell Core on Windows. So you don't have to think about how or if your code is working on multiple operating systems. It's just tested by default. Runs on all common CI/CD products. So we will have a look into invoke build. Some of you might have heard about this. This is a kind of task engine for PowerShell. And if you are putting all your code into this task engine, that means the automation system, be it Jenkins or GitLab or whatever you use, is just calling the PowerShell script and it just runs everywhere. And this is also the reason why we have a single point of entry. So if you want to build your project, just kick off this single file and everything is done for you. Yeah. And that the stuff actually works is proven by the DSC community. We have 50 plus DSC resource modules that are based on that pattern. And the code quality so far seems to be quite good. Otherwise, we would have received more complaints. Yeah, that's it. And now I want to go with you through all the features. And these are the features that the sampler is giving. So first of all, let's start with a module scaffolding creation. So how do we get the module and how can we create something? But first I need to have a look at my pipeline, which finally worked. That's good because I did this on the last minute. Git pull tags. You don't have tags. That's bad. Okay. Anyway, so if we want to start with a new project, then let's open another VS Code. And open a terminal. And what you should have done is previously, is the font okay so, like that? Okay. Install module sampler. That's it. This is all you have to do. Then you have the scaffolding module, and the next thing would be a new sampler module. You can give it a destination path, which would be my drive D. Module type. Here we have a complete sample, DSC community sample, simple module, or a simple without build. So let's do the complete one. Then the module author is me. The module name is test1. Module description, non-existing, non-custom repo module version 1.0, and license type is a Apache. Let's take MIT. That's it. Then you need to specify your default branch, main by default, and the owner of the GitHub repository that is finally hosting that repository. So that would be me. We want to have Git version. We will come to that later, what that is. And we also want to have code coverage. We will have a look at code coverage also later. And then it creates you all the necessary files to get the build engine going. And let's open that folder. And this is how it looks like. So you have a output folder that is later receiving all the files, the artifacts that your build pipeline creates. We have a source folder, and we have a folder for tests. So this is actually a pretty normal structure, nothing special here, right? In the main directory, we have some additional files, like the git attributes and git ignore, also pretty common. We have our build script, and the build script is connected to the build.yaml, because here we can define which kind of tasks we want to run in which order, and how we want to group the tasks. Later we'll have a look at the task. We have a changelog, which is automatically managed for us, and some other files that is more of information. And of course the git version file, which configures how our versioning should take place. So a few words on that. If you are doing changes to your code, then you don't want to control the version number by yourself. Usually you want to have a rule set, and the rule set is increasing the version number depending on the commit message. So if you do a fix, then the patch version is increased. If you have a minor change, then the minor version is increased, and you have a breaking change, of course, then the major version goes up. And having this in place is kind of taking the burden away from you to control this manually. It's just a process that happens out of the box, and the version number is something that is increased automatically. Yeah, and then we have something, I think this is the first thing we need to discover. We have the required modules file. Does anybody know where this file belongs to? Which module is going to use it? PSDepend. Who is using PSDepend? Not so many, yeah? So this is this is why I think this module is so great, the sampler, because it takes from the community all these best practices, and one best practice is using PSDepend, and kind of forces you to use it in a positive way, the force, right? And PSDepend is a module which is downloading the dependencies and is the key to make sure that your build engine and the build script is working on any machine. Because if you put this into a CI/CD release pipeline, then the build script is running on some worker in Azure or on a GitLab worker. So this machine is usually not configured at all. It's just a plain Windows or plain Unix machine. So you need to make sure that the dependencies are available that are required to build your stuff, right? Or that are connected to your solution, for example, DSC Resources. And here we can define a list of resources that is being downloaded before the build starts, and where to put it, and of course also where to retrieve the information from. So if you have a private repository, a local one on-prem, for example, then of course you could change the name here. And if you do something like a GitHub work or a Azure worker would do and call the build script before having done anything to your solution, the first thing is we are starting the bootstrap process. That means in the background we are making sure that we have the right version of PowerShell get and package management. And finally, we will see that the modules defined in the PSD1 files are dropping into the required modules folder, right? So this is one of the important things, dependency management or dependency resolution. It happens automatically, and you don't need to care about how you get the stuff if you have successfully defined it just once. Good. Let's have a look at the slide. So we have covered dependency resolution. Any questions on dependency resolution? Actually, quite an easy topic, yeah. Let's have a look at the next thing, which would be the task runner. So we have triggered the build script, and the build script magically knows what to do, and this is because we have a file called build YAML, and in the build YAML file we have defined various kind of task containers, which is a workflow that consists of a build workflow, a pack workflow, and a test workflow. And every workflow consists of a bunch of tasks. So you may question, where are the tasks actually coming from? And I think we have to wait until the dependencies have been downloaded. Oh. Luckily, sometime in April, the PowerShell gallery has been received an upgrade. Before, it was sometimes horribly slow, and it was totally unreliable to use it in demos. Nowadays, it has gotten a bit better. Here we go. So, and the output shows you that we are loading various tasks from sampler and also from other modules that are kind of coming with sampler. So, and if you have want to understand what tasks are available, then you can control this by kicking off the build script again. Build script dash task question mark. And this gives you a list of all available tasks. Here we go. Unfortunately, the naming convention is not that good, that it's not very intuitive sometimes, but you get used to it. Yeah. And if you think that you need to do something extra for the build, for example, you want to have, after the build process, some file manipulation or whatever, then you can, of course, create yourself a folder here, which is the .build folder. In here we can have a file which is called mytasks.ps1, and in here we do a task, which is mytask1. And what it does, it is just printing out a get date. So let's see, does this task appear in my task list? There it is, my task. And then you can put this task at the position where you think it should be invoked by just getting back to the YAML file, to the build YAML, and putting my task 1, for example, in the build right here. My task 1. What is the right name? My task 1. Yeah. And if we trigger the build script, this is normal. Then let's see, where is it? Here it is. So we are starting with cleaning up the solution, which is also important. So every time you trigger the build script, it removes whatever is in the output folder, because you don't want to merge some artifacts, you want to start fresh. So we are cleaning up the output folder, and then because we changed the definition, the next thing is we are calling my task, which is this one. It just prints out a date, where is it? Here, and then we are going forward with the default definition, right? So this task engine is actually just giving you a kind of control over the flow and let you define how the build process should look like. And if the things run locally, you can be pretty sure that it runs on every build engine or on any build worker that is being spinned up by whatever automation solution you use, right? There is much more complexity in invoke build. You can also make tasks dependent on environment variables, dependent on some circumstances. You can add filtering to it, but I think this is a little bit too much. Just give you an idea that we have this task engine, we can control or we can define the flow, and this gives us the flexibility that we need. And you can also inject tasks if the build engine does not exactly do what you want. For example, we have a bug on Windows, not a bug in sampler, but I think it's PowerShell itself, that the PSD1 file is always encoded as UTF-8 bomb. It's fixed in PowerShell 7, but so if you have a build worker that is running on PowerShell 5, you may want to take the PSD1 file, convert it to a different encoding, and then store it again, right? So this is one of the tasks that I have added to a build engine in some projects to make sure that the encoding just works. Okay. Yeah, next thing is, how do we actually know that the encoding works and that we have the right encoding? The term for that is linting. What is the module that we can use in PowerShell for linting? Any idea? ScriptAnalyser, right? I think most people know it, most people have seen it, but are you using it in your modules? Are you actually applying it everywhere? Yeah, we should, but usually we don't. So in here we have a kind of also enforcement of that, and let me show this in the project that I've created in the morning. The PSConfE test module 10. It's also available on GitHub. I will leave it there so you can download it for reference. And here we have, let me trigger the whole build process and then you can see what I mean. This is all the linting stuff. Okay, done. Let's go from top to bottom. We are starting, oops, here. First of all, okay, that's not necessarily linting, but this test makes sure, of course we use Pester, that the changelog has been edited. And I guess everybody has experienced the problem that you do some changes to your code, you forgot to update the changelog, and the next day or the next 2 days you realize that something is missing in the changelog, and then you have to go through your commits to identify what have I actually done, right? So here you are forced to update the changelog. So if you, it's just a test in the, or we are just using the git exe to verify if the changelog has been edited. We don't know if the right stuff is in there, but it just gives you a warning if you have changed some code but forgot to update the changelog management. Then we are having a look, is the help existing? The comment-based help for the functions that we have, right? Then we have a look at, what is this one here? Context. Now that's not necessarily linting, that's the text. Linting is down here. Changelog management again. Should not contain any files with, Unicode file encoding, right? Should not contain any file with a tab character. We want to replace tab characters in 2 or 4 spaces depending on your definitions, right? Should not contain empty files. So all these things that are not very important, but they are nasty, right? It spoils the code quality and it makes harder for your colleagues to work with the stuff and doesn't look very well. And all the stuff here is enforced. Of course, you can define also additional rules if you are not happy with what we have here. And this is done in VS Code, PSConfE settings, and you can remove rules if you are not happy with them, add some, so this is completely dependent on you. But it's important to have, as a company or as a department, some kind of rule set that everybody agrees on so that we have a similar understanding how code should look like. Yeah. Linting enforced automatically. What else do we have? Testing and code coverage. I think, who's always implementing Pester tests for the code? Yeah, so I don't raise my hand either because usually there is no time for that, but we know we should, right? And the next step would be also code coverage, because if you are just adding Pester tests, you have no idea if these Pester tests are actually targeting your code. So we need to know what is the code coverage at the end to make sure that what we test is actually what we have. And if we go back to the output, then of course you have seen a bunch of Pester tests running, and in the middle here we have also the code coverage. 100%, pretty unrealistic, right? So if you reach 80%, then you're quite good. Usually I'm with 50%. And code coverage means that Pester is testing or is checking that our Pester tests are actually hitting every line in our code. And here it's pretty simple because this demo project consists only of 2 functions. So we have a function which is a private and a public. The private function is not doing very much, it just returns whatever we give in. So we have a parameter private data, it just returns the private data, pretty simple. And the public function is using the private function. So that's all we do. And the Pester tests are just calling these 2 functions, so it's quite easy to reach a code coverage of 100%. Yeah. Code coverage and Pester tests. And we also make sure that every function is covered with a Pester test. So we have actually 2 kind of safety nets. One thing is there a Pester test for the specific function? Plus, is the code coverage testing all the lines in there? Okay, what else do we have? Code coverage, testing, linting. Is there anything that I would like to... Yeah, private function. We talked about private and public stuff. So how does the module actually look like? Because I told you the more functions or the more function files you have, the longer the load time is. So actually we want to have the comfort of dealing with one file per function, but at the end it should be merged into one big PSM1 file. And this is how it looks like. We have our output folder. In the output folder, we have, of course, the test results. We have the updated changelog, the release notes, plus a folder that has the same name as the solution that we are working on, the PSConfE test module 10. In here, we have the PSD1 file, which is getting also controlled automatically. For example, the version number is updated depending on Git version. The functions to export is also maintained by the module. So the module only puts functions to export in here that are part of the public folder, right? Everything in the private folder is just not being added to the functions to export list. And and of course also the release notes are being managed automatically, including preview versions. Here we have the changelog being added to the PSD1 file, so that you know in every new release what actually the last elements in the changelog were. Plus we have the PSM1 file, and the PSM1 file contains a marker from where we get our content. Then comes the actual function, and then the end marker plus the new region for the next function, right? So it's just merging the stuff together. And this is based on the module builder, right? Also a pretty famous module that is kind of a de facto standard in PowerShell, and sampler just forces you to use what is the standard and what's the best practice, right? Any question on the structure? Any question about this private public stuff? No. Do you use this heavily? Do you always think about if a function should be private or public, or is it everything that you do just public? Right? Was it the question? Okay. Okay, yes you do. Yeah. It's mainly for not confusing people, because we all have some helper functions that are not very well documented, that do not have a well-defined interface, and then making them public is just confusing the user. Okay, so, yes please.
Where would you put stuff that you normally have in the init file?
Put that you have where in?
In an init file for the module.
In an init file.
So I put .source file in the PSM1.
Yeah, there is a solution for that. But I don't remember. Let me see. Was it here in Commentars where we use it? Build YAML. Let me spend a couple of seconds on that, and if I don't find it, we have to discuss this offline. It was not in the build YAML. It was. There is a prefix. It's called Prefix. Do we have a prefix usage here? No, I don't. Yeah, so there is, unfortunately, the YAML document file is not very well documented. So it's kind of hard to understand what options you have available and what to put where. But there is a prefix section, and the prefix section is just taking files, putting them at the top of the PSM1 file, and the postfix section that is putting it at the very bottom. So you have this kind of flexibility. Yeah. If it's important to you, then just let's talk after the session. Yes, please.
So how do you handle some other dependencies? For example, you want to have some DLL, some JSON files, you name it. How do you handle?
Good question. Yeah. So we have in the build YAML file a section which is called. Here we don't have it. I have removed it here. Let's go to the project that I have just built. Here, copy paths. So this gives you the flexibility to copy somewhere from wherever you want. Plus, you can also add modules into here. So you can have nested modules that will be either downloaded or being part of another solution. So it's pretty flexible, right? So nested modules are supported, and copying stuff from wherever you want as well. Any other questions so far? Good. Back to the slide so that I not lose track completely. Dependency and templating. Right, the whole thing is built on module builder, so the templates can be also manipulated or changed depending on your needs. I must confess, I know the theory, but I have never played with it because the templates are pretty much what I need, so there was no reason for me to temper them. We talked about changelog control, we talked about versioning a bit. Yeah, by the way, versioning. If you want to have an idea about how the version is being created, then what you can do is call git version manually. So first of all, you have to do a choco install git version.portable, and then you have the git version exe locally on your system, git version. And this is what actually happens also in Azure DevOps. Git version is called, and by means of the commit message, it evaluates the next version, right? And usually we are always in a preview version, and if you want to do a next release, then you have to work with git tags, right? Then you would give this version a new tag of 0.3.2.1, push the tag, and that would be the next release. And everything that you are just pushing without a dedicated release is a preview release, which is also quite comfortable, so you can give your customers or your internal clients a kind of test version all the time, or they have a chance to always grab the latest build, but they can immediately see which one is supported and is just for testing purposes. Okay, let's have a look at the publish task. So what kind of publishing sequences or publishing tasks can you imagine if it comes to PowerShell? Well, that's the most obvious one. Right, put it in the gallery. Is there anything else?
Compiling everything into a single file, so you don't have to load so many files to get it to module.
Yes, as well. Right, but that's part of the build process then, yeah? But anything else that comes to publishing? Please. Pardon? Yes, that's also part. Yeah, we have a pack task, and this is creating a NuGet file, and then you can put it wherever you want, right? Even locally. And another thing is a git release, right? Because one thing is pretty important, and unfortunately I didn't get it to manage, so I can only demo it with one my already working solutions. DSC demo, for example. Let's see if it works here. Right, so we have a release. So the sampler also uploads all the artifacts to GitHub, and pretty importantly, it also adds a tag, which is the version number. Because if we are going to calculate a new version number, we need to store the previous version somehow. So if this tagging doesn't work, or if you are not actually doing a git release and you're losing the tag, then the version number can't be increased automatically. So the publishing task is, of course, most importantly, publishing the stuff to the PowerShell gallery, as well as uploading it to GitHub if you want to. Yeah. So not everybody wants to publish stuff on GitHub. This is why find module sampler star. Great. Yeah, let's do it just again. So we have the sampler, which is the module that I'm currently showing you, but the publishing tasks are part of separate modules. And what these separate modules are providing is just another task sequence. And these task sequences are important then to deal with either GitHub or with Azure DevOps. And we have even another one. I'm not sure why it is not showing that. There is another module called sampler.dsc release pipeline, which is then having all the tasks to interact with DSC and connect these two projects, right? So if you're working locally, then I think Azure DevOps might be, well, in a more personal space, Azure DevOps might be the right thing. Otherwise, it's GitHub tasks. Yeah. Good, and let's do some build process just to see if everything works as expected. So if we do some change here, source. Let's go to public and my dear 2. And if we build this, then we should run into an error. Not yet, because I haven't committed the change. So let's commit the change. Changed message. Do it again. And sampler should identify that the changelog hasn't been updated. Yeah, there it is, right? The changelog has been updated. That is what we expect. It hasn't. So let's go into our changelog. Unreleased section. That should make it happy. And because we are very sure that the build is going to work, we are committing our changes and pushing it. Updated changelog. You will find these kind of commits in my repositories pretty often. After Git sampler has reminded me to update the changelog. Okay, good. And if we go to Azure DevOps and have a look at our release pipeline, then it should already be running. Not yet. Takes a bit here, but in the meantime, we can have, well, there it is. And let's have a look at one of the pipelines that have already worked as expected. So the build should be pretty familiar. Everything that we see here is exactly the same that we see in the pipeline, in the local PowerShell, right? Exactly the same output. But what we haven't seen yet is also the testing. We have seen the testing just once on our local PowerShell, but here you can see testing happens on Linux, Windows PowerShell, Windows PowerShell Core, plus macOS, and finally we have a task that is merging the code coverage from all these various processes and publishing one file. And then finally we have our deploy module task, and the deploy module task is, of course, publishing the module to PowerShell gallery, so we need to have the PowerShell API key somewhere in our Azure DevOps, and it also sends a changelog update to the to GitHub. So that means changelog means we are taking from the unreleased section everything only if we're doing a new release. So we're taking the unreleased section, putting it in the correct version section, and creating a new unreleased section. And this is happening automatically in the build pipeline. So then sampler is taking the change, creating a PR, merging the PR with the main branch, and we can start from scratch, right? So this is also quite nice that you don't have to know which changes to actually put for the current version number, because the unreleased section is helping you organizing your changes and then putting them just at the right place. Yeah. So the release process obviously works, because if I go to the PowerShell gallery, how was my module called? Here it is. 0 downloads as expected, and 33 minutes was the last version updated, and we can see also the version number is increasing depending on my commit messages. And if we would have enough time and wait another 10 minutes, then we would see that another version is appearing here. Yeah. Good. I think that's pretty much it. Half an hour. Yeah. So it's extensible, as I mentioned already. It can be used for creating Azure Guest configuration packages, for creating Chocolatey packages, the NuGet files. We have the GitHub tasks extra module for GitHub interaction, the DSC pipeline one if you're interested in DSC, and this is also the one that we use in the DSC workshop for those of you who have seen the other session that I've given. And which is pretty new is the Azure DevOps tasks module that is specifically meant for also for on-prem installations, that you can use the same techniques to publish your stuff on-prem or on Azure GitHub Service, of course. Please.
What about comment-based help system?
Yeah, we do. There is a doc generator which is taking the comment-based help and put it into kind of markdown format. This is always implemented, yeah. I haven't got it to work because of some little details. So what's very important in this project is at the beginning it's a bit frustrating because, as with many community projects, the documentation is not as it should be. It took me, to be honest, at least a day to make some effective use of it and to get accustomed to how the YAML files work. But then you realize that you get so much in return because of all these bits and pieces that we can see here, that it's definitely worth spending some time. And I was showing this to a bunch of my customers, and we have now about 15 customers using this for their internal PowerShell releases. And yeah, that helps them just keeping the standard up, and especially also have a standard that they can rely on between multiple departments. Yeah. So at least a day, but then things should work a bit smoother. Any questions, please?
I saw that by default we was using GitHub. Is it easy enough to change your source control to local one, basically?
You mean, is it easy to change the source control from GitHub to?
Yeah. So, well, I just remember at the start it requested or prompted you for your GitHub user.
Yes, it is. So most of my projects are running on Azure DevOps, so with the customer projects, and it's extremely easy. Yeah, I don't even. Is there anything that doesn't work? Yeah, previously what didn't work is the tagging. So the sampler wasn't be able to send the tags out of the box to Azure DevOps, so therefore the versioning didn't work. But thanks to this module here, the new one, this is also done, yeah.
So we tend to use TeamCity, so is it still compatible with that, or is it only?
I guess so, because Azure DevOps doesn't have an interface for managing the pull requests. So what we do is just we use the git exe. And if TeamCity is happy with the git exe, then it should be fine. Yeah, yeah. I would expect a little bit of development work. So I wouldn't expect some things to not work as expected. But I mean, create an issue, help us getting also TeamCity covered, and yeah, then it should work. Good. Any other questions? Perfect. So I will upload the slides to the PSConfE repository. I will leave the demo repository for a couple of months because I'm on vacation anyway, so I won't clean up after myself. And yeah, happy to use it. It solved many of my problems, increased the development time, the quality. So you can also only gain quality if you try to adopt this kind of standard. Good.